How's everybody doing out there? Well, welcome to day one of Corona Online School, fall 2020. So it was nice to see a lot of familiar faces on the roster this semester. So I'm glad to see so many of you guys signed up to take Math 113. This is an awesome course. I love teaching it. It talks about geometry. We'll get to do lots of fun stuff with compasses, protractors, and other manipulatives that unfortunately will probably be virtual since we won't actually get to meet in person. But all in all, it still should be a lot of fun. So at this point in class on the first day, usually I would talk about the syllabus and that kind of stuff, but I'm just going to let you read the syllabus and stuff on your own, and definitely email me if you have any questions or anything like that. Otherwise, we'd also be doing like an introduction for everybody. So I actually saved that as a collaboration. So I want everybody to do a little introductory video to introduce themselves to the class so we can all put faces with names. And that's when I'll talk about myself also. So I'll make my own introductory video and upload it for you guys to see. So otherwise, with that in mind, I say we just dive in and start working on some classwork here. So if you look at the very first one, part one is an exploration where we kind of talk about some of the basic things in geometry. And so if you notice, if we were in class, I would have brought pretzel sticks and mini marshmallows for you guys to actually build these things with. So since we're not, you can use whatever things you have at home. If you have Q-tips, toothpicks, or if you just want to draw it, either way, kind of go through and demonstrate what each one of these, what you think they would actually look like by trying to sketch them out or use some kind of things to draw them. And then once you're finished, actually take a picture of this and upload it to the collaboration space so we can see how everybody did, compare our answers, check and make sure everybody's on the right track and knows what's going on. So at this point, go ahead, kind of pause the video, go do this exploration, and then when you're finished, unpause the video, and then we'll kind of continue on with the next part. All right, so hopefully you had a good time with that. So if we notice, geometry is all about different shapes and things like that, but everything kind of builds around three main things that are actually undefined. So points, lines, and planes. So we do talk about points, lines, and planes with definitions, but there's really no kind of formal definitions to these guys. So we will talk about them in the PowerPoint slide that you're going to look at next, and that'll kind of define a bunch of different terms and things like that. But what we want to do is think about some of these from like a dimensional standpoint. So for example, if I asked how long was a point, how long do you think a point is? Well, be careful because we can draw points different ways, like, so I've got a thin point and a thick point, but don't think about those as any kind of length or anything like that. Like there's nothing to walk across or anything like a line or a floor or something like that. So when we think of how long a point is, it would say had no length, for example, or none. Same thing with width. It doesn't have any kind of width or anything like that. So even though I drew one thin and one fat, don't think about it that way. So again, it doesn't have any kind of width. And is it tall? Does it sit off the paper or anything like that? Is it kind of a three-dimensional? So again, no in that case. And so when we think about dimensions, like, first dimension, second dimension, third dimension, technically a point would actually be kind of a zero dimension. It doesn't actually kind of live anywhere. It's just a little dot, a speck, and things like that. So it's kind of a zero-dimensional object. It's a little bizarre. So what about a line? Could we talk about a line having length? Sure, a line goes on and on and on forever. So how long is a line? So technically, we can say it is infinite length. So again, if we think about our line, kind of goes off in different directions forever and ever and ever. And so how wide is our line? So again, that's kind of just measuring the length of it. So again, don't get distracted by, if I use a big font and my line looks like that, it's like, ooh, that one's really wide. Not really. Don't think about wide that way. So what we're doing is we're trying to think about like in a dimensional aspect. So in this case, our width would be again none. So kind of the same as the point. And same thing, how tall is a line? So again, it doesn't come off a paper or anything like that, so that would be none. But then a line would be one-dimensional because it goes right or left. So in this case, so we could say it has dimension 1. All right. So what about a plane? How long is a plane? So down at the bottom, I've got kind of a picture of what a plane looks like. So if you look at the very bottom, a lot of times we represent a plane by sort of diagonal piece of paper cut. And so this plane technically keeps going in this direction, this direction, this direction, and this direction. So even though we represent it kind of like it looks like it's bounded and has an end, it really doesn't. It keeps going on and on and on and on forever. So think about a floor, think about a road, things like that. So things that kind of go on and on and on forever. So how long was a plane would be kind of looking at this length here. So again, just like a line, it goes on forever and ever and ever. So how wide is a plane would be kind of out this way. So how far up and down does it go? So again, it goes forever that way. And so how tall is a plane? So notice I've got a line coming up off of it, but it's not actually on the plane. So again, the plane is flat. So think of it like a piece of paper or a table. So it doesn't actually have any height or anything like that. So in this case, it has no height. And so a plane would then be 2 dimensions, because in this case I can go kind of left or right or up or down. All right, does that make sense for everybody? All right, perfect. Again, if you get stuck on anything or if you have any questions as we're going along, feel free to post messages up on the message board on my Teams. Send me a message, send me a chat, whatever. So just make sure you don't let yourself get behind. So part 3 is all about definitions. So if you open up the PowerPoint, I won't go through these for you, but write down the definitions, draw the pictures as good as you can, and if there happens to be notations for these, go ahead and jot down what the notations are. So at this point, go ahead and pause the video or stop the video and come back later. Fill in the definitions so that way we've got official definitions for all of these words. And then finally, once you're done that, we've got part 4. So a postulate is a mathematical statement that we kind of accept as true. Like we don't have to prove it or anything like that. So we know it's true. And so I'm going to do the first one. I'm going to let you fill the rest of these out on your own just to kind of test and see what you think. So in this case, we're going to fill out all the postulates using one of the undefined terms. So the only answers that we should get in this case are going to be the point, the line, and the plane. That should be the only possibilities. And so once you figure out what you think goes in there, or you may have to actually sketch it a little bit to try to figure out what it would be, make sure you draw a picture to kind of go along with it. So in this case, the intersection of 2 lines is well, if I'm not sure, I could always just sketch 2 lines, and see what happens. So in this case, I've intersected these 2 lines. Where do they intersect at? It looks like that common point in between them. So in this case, our first postulate would be the intersection of 2 lines is a point. So you try 2, 3, 4, and 5 on your own. Again, your only possible answers are point, line, or plane. So again, if you need to, draw it out to kind of sketch and see what you think it'll be. Feel free to collaborate with each other in class. You can chat with each other, text each other, whatever, to kind of make sure you check your answers. Ask me if you're not sure. Otherwise, let's move on to part 5. So this is another exploration that we're going to do as a collaboration. And so again, we would have had manipulatives to use in class. So again, feel free if you want to use Q-tips, toothpicks, or if you just want to draw it. I want you to kind of go through and sketch what you think a 0 angle would look like, an acute angle, a right angle, an obtuse angle, a straight angle, and a reflex angle. See if you can remember them. Like I said, don't try to look them up at first. Try to sketch them and see what you can think. I'm hoping that you recognize at least the first 5. You might not recognize the 6th one, and that's okay. I'll explain that one if you don't understand what it is. But once you're finished part 5, making your sketch, again, take a picture of it, upload it to the collaboration site so we can kind of compare our answers and see how we did. So at this point, again, pause the video one more time, do this exploration, and come back when you're finished. All right, so part 6, so we're actually getting into measuring angles with a protractor. So in this case, the first page I've actually got protractors drawn on here. For the second page, I was kind of assuming people might have a protractor. If you don't have a protractor at home, can you message me and let me know? Because I can upload a classwork packet that actually puts the protractor on there so you can kind of finish them up. I did find a good deal at Staples. I was there this weekend and they had a good deal on protractors for $4. So feel free to like run over there. They had protractors, compasses. It was one big pack for $4. It was a really good deal. And we will use some of that stuff later. So if you can get them, it would be great. So in this case, our protractor, if we notice, it's got numbers kind of on the outside and it's got numbers on the inside. And so what happens is it kind of depends on the way the angle's drawn, whether you're going to measure the outside or the inside. So the way we always do these, this arrow is always going to be kind of the center of our angle. And then the other side's always going to line up either this way or to the left. And I'll do an example of that one too. And then it might shoot up this way. So in this case, whenever our angle is over on this side, then we're always going to read the outside numbers. So in this case, the angle I drew looks like it's about 50 degrees in this case, because I'm only looking at this outside number. So if our angle's drawn the opposite way, let me change colors. And so again, if it starts here, but the opposite side that goes through 0 runs over this way, well now we're going to actually use the inside numbers to measure our angle. So if it were, say, up this way, then in this case we would say that angle is 70 degrees because we would use the inside. Another thing to think about is if you remember what acute and obtuse angles, that'll also help determine which one I should actually use and stuff like that. So again, that's kind of a nice refresher for protractors if you haven't used them in a while, or if you've never used one, this hopefully gives you a little hint about how to use them. So in this case, how many degrees are in our semicircle? So as we can see, doesn't matter whether you look at the inside or the outside, they both go up to 180 degrees. And so that's true in this case also. So our semicircle is going to consist of 180 degrees. And then I'll leave you answer these guys on your own. So what type of angle is ABC? So again, if you were able to answer the part 5, you should be able to figure out what kind of angle it is. And then again, just read off the coordinates to figure out what the degrees are and mark those down. And then for the next page, again, if you've got a protractor, go in and measure them. Draw number 5. You can do 6 whether you have a protractor or not, which is fine. But if you don't have a protractor, again, let me know, and I'll upload a classwork packet that'll put the protractor on 4 and 5, just like it has on 1, 2, and 3. All right, so work on those guys real quick. And then finally, the last thing in this section is a nice example to talk about degrees is actually a clock, because it actually goes around a circle and things like that. And so if a half a circle has 180 degrees, then that means a full circle would have 360 degrees. And so in this case, the way I've got these tick marks, we want to figure out, what's the degree increments of each of these tick marks. So what we want to do is first kind of calculate how many tick marks we have. So we've got 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. So I've actually labeled these just like you would a clock. So we've got 12 tick marks in this case. So to figure out the degree of each of these increments, then what we want to do is take 12. Whoops, that was not good. And divide it into 360. So in this case, if we do the math, it looks like we'll end up getting that each of these little tick marks is 30 degrees. So what that means is if I were to kind of take a line and go from 12 to 1, this would be 30 degrees. If I went from 1 to 2, this would be another 30 degrees. If I went from 2 to 3, this will be another 30 degrees, and you can just kind of keep going around and around and around. So with that in mind, these can be a little tricky, but I'm going to leave these guys for you to try. So try 7, C, D, E, F, and G on your own. If you get stuck on it, let me know. I'll give you a hint and stuff like that. But based on what we've done, hopefully I think you can kind of knock out what the answers are for these guys. So good luck. Welcome back. I look forward to talking to you guys throughout the semester. I'm glad to have you guys back. And if you have any questions, don't hesitate to ask.